Good day. Thank you for watching my portfolio video. And if you have any suggestions or about improving this presentation or the code shown below, please comment it down below. The code I'll be going through today, you can find the link for the code in my description to my GitHub repo down below as well. Alright, let's get down to it. So the dataset we'll be looking at today is the dataset about diamonds, right? I got it from Kaggle, and this dataset contains data such as the price of the diamond, the carats, the cuts, the color, as well as the clarity of the diamond, right? And other metrics and measures. And so first step, we import the necessary libraries that we're going to be using for the analysis today, as well as importing the data itself. I had downloaded it and now I'm just importing it locally. Thereafter, the first and most important thing to do right after you get data is to check for missing values. And from up here, I check for missing values per rows and per column, as well as later on I check for duplicate rows, right? So yeah, in case there are any duplicate rows in this data, we check for those as well. And when you run the code, you find that there are no missing values, luckily, and there were some duplicate rows that were detected. There were 146 of them, and they were dealt with, right? Thereafter, we move on to splitting the data, or the columns per se, into both continuous and categorical columns. I use the basis personally that if a column has 10 or less unique values, it's categorical. And so I split my columns into those, and then for those categorical columns I do frequency tables for them, right? And from there you can see that the cut, those 39% of the diamonds were an ideal cut. 20% of them had the G colors, probably slightly yellow I believe, and as you can expect, things like internally flawless diamonds had a very low percentage of 3.32. Alright, moving further along, we now do the exploratory data analysis for the continuous columns, right? We get to see the accounts and their quartiles, and from these we could recognize a few. I did not expect that X, Y, and Z started 0, but maybe a bit more domain knowledge would help. Alright, so this is the general distribution of the continuous columns, and then moving after, I append the price again to continuous columns, and then I do a Shapiro normality test to see how normal the data is. Alright, albeit it's a bit touch and go for values greater than 5,000. Okay, I'm sure I ran this, and then let's look for, alright, now let's do the correlation plot. Yeah, this is the correlation plot for the continuous variables, and since price is the main target variable here, we looked at it's correlated to XYZ as well as the carat, but it's not so correlated with depth and table. Okay, cool. And then having seen those high correlation numbers, I did a multicollinearity test, and most of them were greater than 10 except price, depth, and table. And given this, I concluded that it's best I do a regularized regression as opposed to simple ordinary least squares regression, right? And so from here on, I can start developing my goals. Like, okay, I want to create a model that predicts price based on the other features using elastic linear regression, as well as testing out k-nearest neighbors, support vector machines, and a neural network. And I asked myself the question, are these low correlation features worst predictors for price? And secondly, you ask yourself, we then do a new column, we predict if diamonds will have a better than average price, right? This is going to be my categorical prediction. So to do that, I create a new column called above average, which is 1 if the price of a row is greater than the mean price or the average price, right? And it's 0 if not. We use this to predict whether or not a diamond will have above average price, right? And hereafter, I do a chi-square test to test for association between this newly created above average column as well as the other categorical columns, right? And in doing so, we find p-values less than 0.05, which shows that there's no statistically significant relationship, right? Okay, cool. We failed to reject the null hypothesis. Anyway, we also see the value distribution of the newly created above average column, that 63% of the diamonds are below average and only 36% of them have above average price. That will be useful later on. Here I observed that cut, color, and clarity are ordinal data variables, and after ordering them, I compared the price taking into account their ordering. I did not see any trend when looking at the median. I just observed that the IQR body increases somewhat as we head towards ideal diamonds, but there is a genuine diamond observed here, in that there is sort of a decrease in the mean value of price as we head towards decolored diamonds, which would be unexpected since these are nearly colorless whilst these are somewhat yellow. And similarly, we observe a trend as we move from somewhat low clarity, slow flawlessness to this is internally flawless. And when you look at this, we see that, yeah, although the most of the body is somewhat below 5,000, it also shows that there's a lot of outliers for internally flawless diamonds, which tell us that it may be the case that there's so many outliers because for these high clarity diamonds are probably auctioned off, and there's a lot of erratic price behavior in these auctions, people splurging money, I guess, and because of that we observe a lot of outliers in the price data. Alright, moving on to modeling, let's get on to the good stuff now. Before I can model, we start by scaling our feature data, our continuous features, but from there I remove the price first just to ensure that I do not scale my price. But then after scaling, we also look at a train test split of my data set. I did a special thing with my categorical data for the one where we're going to be predicting above average, where I stratified according to above average to ensure that there is a good class distribution that is reflective of the original class distribution across my training and test data, right? And so after that, I trained a regression model using elastic net. This is regularization of both L1 and L2, and the alpha, we were grid searching for what was the best alpha between the smallest to a very large alpha, and from there we got a model where the best parameter was an alpha of 0.01, and that is its MSE, and this is the chart, right? And this is the chart of where the blue or this dotted line is somewhat the actual prices, and the red is what the model actually predicted the price was. Moving on from the regression model to its coefficients. From its coefficients, we can see that carrots and the clarity columns are somewhat the most important in somewhat determining the price, right? These were the most significant sort of in determining the price, and table and depth were amongst the lowest, which answers one of our questions as to whether since these had low correlation, the voluminous with low correlation, and you can find them here being not so strong predictors of price. And moving further along, this is me creating a neural network that also predicts the price. I grid searched through it to find the best architecture for that neural network, and the output was that 2 layers each having 50 neurons was the best architecture, right? And here is a scatter plot which shows the actual value, right? The actual price versus what the predicted price was, and we see a very strong positive correlation, which indicates that the model was somewhat spot on, I could say, in predicting the price. A better representation of that is this curve here. We see again the actual prices in blue dots, whereas the yellow represents the model predictions. We see that For low prices, the model was pretty accurate, but as prices got higher, there was a lot more variability in the model, which is somewhat to be expected since, as I said earlier, higher priced diamonds, I would like to believe that these auctions for them, and at auctions really it depends on more on who's there and how much they feel like splurging on diamonds, I believe. And moving on to logistic regression and to predicting whether or not a diamond is above average or not, I was still grid searching, and we can see here that we came out with a 97% accuracy, which is very pleasing given that I train test split my data. And similarly with a neural network, earlier was just a regularization. Yeah, this was a regularization. This was like logistic regression regularized. And here is a neural network which produced similar output. And here is a decision tree. And here is my decision tree as well, which also was used for predicting whether or not a diamond would have above average price. One thing I like about decision trees is this tree structure. You can sort of use it, it can be a tool to help you build a mental model of under what circumstances would lead to whether or not a diamond is above or below average, will lead to predict whether a diamond might be above or below average in terms of price. This is a bigger tree. This one was a bit more complicated because I went into, I believe, depth of 9. We did a grid search, and I believe that the best depth was at depth of 9, which makes it a bit more complicated, but otherwise it's still a great tool. I believe let me just end the video here, and once again I thank you for looking at my portfolio video, and once again implore you, if there's any way I can improve the presentation, if there's any way I can improve the code, please drop your suggestions down below if you would have liked to see further analysis. But otherwise, thank you, God bless.